What's up guys, it's Simon Fiaz and today's video is on AQA level chemistry, June 2023, paper 3, multiple choice questions, section B. Question 7, which row shows the number of each fundamental particle in 125 Mg2 plus ion. So we'll get the periodic table. Mg, 12 electrons. Right, it's got 12 here. So it's gonna have 12 protons. So I can cross out B. It's not going to have 12 electrons because it's got 2 plus 12, so we're going to have 10 electrons. And number of neutrons, top number minus bottom number, so it's going to have 13 neutrons, so therefore it's going to be C. Question 8, what is the relative molecular mass of benzene 1,4-dicarboxylic acid? So benzene 1,4-dicarboxylic acid, benzene, and it's going to have COOH, 1, 2, 3, 4, 5, 6, COOH. So what's it going to be? Is it going to be 72 plus 5 plus 12 plus 16 plus 16 plus 1 plus 12 plus 16 plus 16 plus 1. I got 167, which is not correct. 72 plus 5 plus 12 plus 16 plus 16 plus 1 plus 12 plus 16 plus 16 plus 1. And you need minus, it's going to be 166. 166 is the MR, aka the relative molecular mass of benzene 1,4-dicarboxylic acid. Which substance has significant electron delocalization? Graphite. Which reaction has standard enthalpy equal to standard enthalpy formation barium chloride? So it's not going to be the ions, it's going to be that, and barium needs to be a solid, so therefore it's that. That's its gaseous state, that's incorrect. So 10C. Question 11, this is Maxwell-Boltzmann distribution. Okay, for gaseous reactant, what is represented by total area under the curve? Total number of particles present. Don't fall for total number of reactant particles, that's this bit. Question 12, the rate of reaction is greater when a catalyst is used without changing the temperature. Which statement explains why the rate of reaction is greater with a catalyst? Collision frequency increases because the catalyzed reaction has a lower activation energy. Collision frequency increases because of increased average energy. Proportional successful collisions increase because the catalyzed reaction has a low activation energy. Yeah, I see. Question 13. When HF is added to water at 290 Kelvin, its equilibrium is established. At equilibrium, concentration HS with that is concentration F minus that was the value of equilibrium constant in that. So I can see from here that it's 1 to 1. So Kc equals concentration of H plus F minus by the concentration of HF. But because it's that like that, 1 to 1 moderation, I know of that, I can assume concentration F minus equals the concentration of H plus. Since I'm not giving any more information, so it's going to be 2.30 times by 10 to the power minus 3 squared divided by 7.70 times by 10 to the power minus 3. And I get 6.87 times by 10 to the power minus 4. Therefore the answer is D. Question 14. Which oxide is named element in its highest oxidation state? Chlorine in this from minus 2 to... No, magnesium in that, that's plus 2. Nitrogen in that, minus 8. That's going to be plus 4. So, is a named element in its highest oxidation state. Highest oxidation state, in its highest oxidation state. So even though in this case, minus 8, that's going to be plus 4. For that one, yeah. It's going to be magnesium. Because magnesium can only have plus 2, right? Because in group 2, therefore highest oxidation state plus 2. What happens when water is vaporized? Covalent bonds break? No. Intermolecular forces are overcome. Definitely not that one, definitely not that one. And it therefore must be B. When water is vaporized, intermolecular forces are overcome. Question 16. Which species can act as a Bronsted-Lowry acid in aqueous solution? Bronsted-Lowry acid, so proton donor. Proton donor. Proton's obviously H plus. So which one can donate proton? SO42 minus. It's got no protons. BF3. It's got no protons. I'm either HCO3 minus or NH3. Now NH3, it wants to accept H plus to form NH4 plus. So it's not going to be that. It's going to be HCO3 minus. HCO3 minus. Question 17. Which change causes the pH of this much sodium hydroxide to be half at 298 Kelvin? So adding 10 centimeters cubed of water. Well, what's that? What's the moles of that? 10 divided by 1000 times by 1. 0.01. Right? I do 10 divided by 1000 times by 1. 0.01. I want the one that causes the pH to be halved. Adding 10 centimeters cubed of water, adding 10 dm cubed of water, that's not going to do anything, those two. That's not going to cause the pH to be halved. I know Kw is that, and Kw is obviously concentration of H plus, concentration of H minus. I want pH to be halved. H plus equals Kw divided by concentration of H minus. Which one is it going to be? Well, adding 10 centimeters cubed of that. So which one to be halved is going to be that. Adding 10 centimeters cubed, 0.10 moles per minus cube of HCl. There you go. Definitely not that one as well. Question 18. A 0.10 moles per minus cube solution of weak acid has pH star was value of Ka. So I know H plus, concentration H plus equals 10 to the power minus pH equals 10 to the power minus 2.50. And I know Ka equals concentration of H plus squared, in this case, V over HA. I've got H plus 10 to the power minus 2.50 squared divided by HA 0.100. And I get 1.0 times by 10 to the power minus 4, so the answer is C. Question 19. Which statement is not correct about the pair of three elements sodium to chlorine? Sodium has the largest atomic radius. It does. Sodium has the lowest melting point. That's false. That's clearly false. Like, even if you didn't understand, their silicon has the highest melting point. No, sorry. Which statement is not correct? Sodium has the largest atomic radius, yes. Silicon has highest melting point, 100%. Chlorine has highest first ionization energy. Out of those, yeah, it does. But just the idea, sodium has the lowest melting point. Sodium is a metal. So you're telling me a metal has a lower melting point than sodium to chlorine, than phosphorus or sulfur. Yeah, it's definitely going to be B. Sodium has the lowest melting point. That's definitely not correct. 100% false. Equal volumes of pairs of solutions are mixed. Which pair forms a buffer solution? Ammonia and ammonium chloride, ammonia methylamine, ethanoic acid and methanoic acid, hydrochloric acid and sodium hydroxide. Definitely not ethanoic acid and methanoic acid. That's not from a buffer solution. Ammonia and methylamine, hydrochloric acid, sodium hydroxide. No. Ammonia and ammonium chloride. Yes, definitely. Ammonia and methylamine. No. Ammonia and ammonium chloride forms a buffer solution. Barium metals added to large excess of water. Which observation is correct and complete? A colorless solution with effervescence. Which species is the strongest reducing agent? It reduces aging, so I'm looking at the negative ions, reducing agent. And if I look at F minus I minus, which one is further down the group? That's what you have to look at. F minus. Iodine is further down the group than fluorine, so it's got to be I minus. Iodine is further down the group than fluorine. Question 23, which statement about shapes of ions is not correct? NH4 plus is tetrahedral. Yeah. COCl42 minus is square planar. That's false. That's not correct. It is not square planar. Which compound can decolorize acidified potassium manganate 7 solution? FeSO4. Yeah, FeSO4. Can decolorize acidified potassium manganate 7 solution. Which statement about catalysts using reactions at equilibrium at constant temperature is correct? They are always using the solid state. They increase the rate of forward reaction but decrease the rate of reverse reaction. No, definitely not that. They have no effect on the value of equilibrium constant. Boom, that's correct. Boom, that's immediately correct. I already know that. They're always using the solid state. No, that's not true. Making forward reaction maximic. No. Consider this reaction scheme. Which step is shown with the correct reagent and the correct condition? So how would you know your mechanisms and the reagents, and conditions? So step 1, HCl dissolved in water. We go from this ketone to a hydroxynitrile. So nucleophilic addition, HCN dissolved in water. Or step 2, potassium hydroxide dissolved in warm water. I'll form an alkene. In warm water, no. CH3OH with an alkaline catalyst. Step 5, I'm just looking at which ones I can cross off immediately. Step 5, I'm going from this with a double bond to this, no double bond. Hydrogen with a nickel catalyst. Definitely not that. That's called catalytic hydrogenation. That's for nitriles and amines, not that. So I'm left with step 1 and step 4. Methanol with an alkaline catalyst for step 3. No. Let me see that again. Hydrogen with a nickel catalyst. Step 5. Never mind, it is that one. Hydrogen with nickel catalyst. HCN dissolved in water, no. And then I was messing up with the alkaline catalyst. No. Yeah, H2 with a nickel catalyst. H2 with a nickel catalyst. They always like to ask questions about that reaction. H2 with a nickel catalyst for some reason. Question 27. Which process does not involve a heterogeneous catalyst? Catalytic cracking of alkanes. Well, that uses a zeolite catalyst. So 26D, question 27, that's a zeolite catalyst, and that does not involve a heterogeneous. That is a heterogeneous catalyst. Catalyst, which is in a different phase / state to the reactants, speeds up the rate of reaction without being used up, or the reaction without being used up. Contact process, that does involve a heterogeneous catalyst. Decomposition of ozone, yeah, that does not involve a heterogeneous catalyst. Question 28, the equation for the complete combustion of butane is shown. C4H10 plus 6.5 O2 to form 4CO2 plus 5H4. What's the mole fraction of butane in a mixture of butane and oxygen with the minimum of oxygen needed for complete combustion? What is the mole fraction of butane in a mixture of butane and oxygen? So I've got 1 mole of butane over that 1 mole of butane plus 6.5 moles of oxygen. That's the mole fraction. 0.133. So therefore the answer is A. 28. Which is not a possible product of a reaction between potassium hydroxide and this. Alhamdulillah. So A, I replace it with OH. That definitely is a possible product. B, I go from that to acetyl bond O. Definitely not. C, I form a double bond, an alkene double bond, yeah, elimination. Same with D, just in a different place, so yeah, it's B. No way I can form that from just that and potassium hydroxide. Question 30. Most scientists believe that the concentration of ozone in upper atmosphere should not be allowed to decrease. Which statement is the correct reason for this belief? Ozone helps prevent global warming. No. Ozone is an efficient disinfectant. No. Ozone helps from repollutants such as chloroalkanes. No. It absorbs ultraviolet radiation. Question 31. What is the name of compound X? 30D. Question 31. What is the name of compound X? Compound X can be converted into an alcohol in a two-stage process. What is the name of compound X? I start with X. I use concentrated H2SO4 for my intermediate and then excess H2O alcohol. And the intermediate is going to be the alkyl hydrogen sulfates. And now I'm understanding which mechanism this is. Alkenes will react with cold concentrated ferric acid from alkyl hydrosulfates, then hydrolyzes to form an alcohol, excess H2O. So compound X is going to be an alkene. Propanol, aldehyde, no. The answer is A. That's the only alkene there. Ethanamide, definitely not. Methylbenzene, I guess some students could go for that, but methylbenzene, remember, it's just a benzene ring and a methyl group attached to it. There's no double bonds, it's carbon-carbon double bonds, it's not an alkene. Name of compound X, it's got to be an alkene. So it's got to be propene. Question 32, which is the correct equation for the oxidation of 1-phenyl ethanol? O represents oxygen from an oxidizing agent. So in all of these I'm forming water, perfectly fine. 1-phenyl ethanol. So let's draw that out. And then the ethanol. And obviously the OH group has got to be attached to this first carbon, attached to the phenyl group as well. And remember, these just represent carbon. So there's 6 carbons, 1, 2, 3, 4, 5, 6. So if I look at this carbon this OH group is bonded to, it's a secondary alcohol. So it's a secondary alcohol, 1-phenyl ethanol, 1-phenyl ethanol, a secondary alcohol. And I know it's being oxidized. Well, what am I going to form? I'm going to form a ketone. So the first one, A, that's wrong. That says carboxylic acid. B, that's an aldehyde, so that's also wrong. C, that's an aldehyde again, that's also wrong. It must be D, and if you look at that, there's a C double bond O in the middle. That's a ketone. Question 33. The skeletal formulas of 2 compounds are shown. Which method will distinguish between samples of these compounds? Now, got 1, 2, 3, 4. 1, 2, 3, 4. And they both got double bond O. So warming with Tollens region definitely won't, because because distinguish between both these are aldehydes, right? Aldehydes. So if I use Tollens region, it's not. They're both going to have the same silver mirror. Warming acidified potassium dichromate, no. Obtaining molecular masses from high resolution mass spectra, got the same MR or very similar MR. Comparing the fingerprint regions of the infrared spectrum. Which compound is the strongest base? Now, it's not going to be B, because if benzene ring and the nitrogen becomes lone pair becomes delocalized into ring, and NH3 ammonia, no, it's not even bonded to any alkyl groups, anything. NH4Cl or this. Well, what is this? This is a cyclo methane, ethane, propane, butane, pentane, hexane. 1, 2, 3, 4, 5, 6. Cyclohexane. What's cyclohexane? C6H12. So, yeah, because that's going to be attached to C6H12, whereas this is NH4Cl. So yeah, that will be the strongest base. Positive inductive effect, electron releasing character, and all of that. Question 35. Which statement about enzyme is not correct? I really don't like this because I got confused one time in my exam. I just say which is false. Which statement about enzyme is false? Because you could misread it as which is correct, time pressure, etc. So which one is false? You're clarifying it. The tertiary structure of enzyme influences which molecules combine to the active site. The action of enzymes can be inhibited by a molecule that binds to the active site. Computers can be used to design drugs to block active sites and enzymes. That's definitely true. So is that one. So this one again. Tertiary structure influences which molecules combine to the active site. Enzymes work equally well on both optical isomers of substrate. No. They don't work equally well on both optical isomers. Optical isomers, substrate, and yeah, the enzyme. No, it needs to be extremely specific. Tertiary structure influences which molecules combine to active site. That is true. And which one's false? Enzymes work equally well on both. Enzymes work equally well on both optical isomers of a substrate. Question 36. Cisplatin has a formula that cisplatin is an anti-cancer drug that represents replication of DNA. When cisplatin bonds to DNA, which is a correct ligand replacement reaction. Just need to know this, and it is D. Replacement. The correct ligand replacement reaction, replacement of 2Cl minus ligands. And that is the end of section B, aka the multiple choice questions.